this week I think they're fairly simple. So, yeah. Quad, this is week 82 of the Perl Weekly Challenge. I've had a little bit of effort trying to make my audio a bit better, but I'm also going to try harder to actually speak as I do things. Right. Common factors. Two positive numbers. I wonder if this works beyond integers. So, to find the common factors of an integer, I find the easiest way is to, we can zoom in a bit, make the font a bit bigger here, since these are quite simple problems. So I find the easiest way to find the common factors is to take integers up to the desired number and do mod on those, and then find where 0 is the mod. Now, if we get rid of the number itself, then, iota neg1 plus omega, right. So now we don't have the number itself in there. So this finds the factors of 12, and I can find the factors of 18, and I literally just want to find the intersection over the factors. That's 1, 2, 3, and 6. Double check for my sanity. 18, 23, just 1, and I don't know, something like 15 and 30, 1, 3, and 5. So there you go. Let's just stick that in a def and nice and simple. Good. Fair question. Should I attempt to trainify this? Right. So we can actually have a look at that. One issue with trying to turn this into a train in the way that I currently work is trains, tacit functions don't get linked to APLF files by default, and that's usually how I work. So I link my workspace to a folder on my system, and every function I create gets automatically turned into a text file there. The .aplf extension. But to turn this into one anyway, it's basically a matter of just fixing the right hand side here. But the big problem is everything's so monadic. So neg1 plus right tack, yeah, that's fine. But then iota is atop that. We'll try with parens first. Just see how we go. And then it's right tack mod, then 0 equals, and where atop that can all go like this. So this should still work. Nope. Are you for real? Oh, right. Yeah. No, this is right. Okay, where 0 equals that. Can you put a top there? No, that breaks it. So yeah, because it's monadic, stuff just comes out ugly, really. So we won't bother with that. Let's move on. Interleave string. Given 3 strings, A, B, and C, we'll have them as character vectors rather than strings, and we'll want to write a script to check if the third one, C, is created by an interleave of A and B. So interleave of vectors in APL is just comma rank 0. So I don't know, 1, 2, 3, 4, comma rank 0 A, B, C, D gives you the 1A, 2B, 3C thing. I guess we want comma atop that. No? Is it really not? Well, we can ravel the thing at the end anyway, and that's the idea. Oh, because that binds that way. So it'd actually be, at which point you might as well use the trained syntax. Comma, rank 0. Right. That's what it is. And that looks kind of neat. And how will we get our input? We'll call it interleave. Like, alpha is an interleave string of the two strings in omega. So xxy, interleave string xy, x. Alright. So you've got rank 0 / omega. That interleaves x from b, and xy from a gives us c. Oh, so it's either or. So omega, 0.5 rotate omega, and now you've got 2. So what I've done here is just laminate one thing on top of the other. Yep. And then do my interleave across each row. And I can mix that. Or I could just do it with each. Equals C. So I've just jumped in here, not read the question properly. Oh no, okay, mixing is not the one. But I'm also finding it odd. I don't know. Supposed to enclose on that? The point is we should get xyx and xxy. Oh. Interleavers in the whole string. No, it's like any kind of weird combination. XX from A and XXZ from B and the Y from A. Oh my god, okay. Time for brain to engage. Good lord. So if we have X, Y and X... No, hold on. No. Come back here. Alpha index of omega each. We're going to go for a little more complicated example if we're going to go for this approach. XXX, X, ZY from XXY and XXZ. My thinking being, using index of, we should get, it's possible that progressive index of is going to be more up our alley. So let's go apple cart. Alright, so progressive index of is like index of, but with multiplicity included. What that means is instead of just indicating the first index, it indicates the first index if there's one from the left and one from the right. Second index until basically it runs out of the characters to use up. So the first X is in position 1, second X is in position 2, the first Y is in position 6. Right, so this gives us a good indication of whether we can fulfill stuff on the left from stuff from the right. And what does explanation mean? Well, this to me just says, so the output we can get from literally just flattening this and saying, are they all less than the length of our string? Right, so are all the indices valid indices into the string? And we want to know if they're all, I prefer those types of things with little trains. Are they all in there? Yes. So then you can build up like that. So then it is possible to build up the string on the left from the two strings on the right. Of course, this thinking falls apart as soon as I take the third example. I go yx, x, and it says, of course you can. But that's because PDI is not the one. That just tells you if the membership constraints are met, not that you can arrange them in such a way. The problem I'm having is the chopping up though. But they have to be in order. You can take substrings from your original ones as long as they're in order. So does that mean the criteria is just that these numbers be ascending? So the first example, xyx can make xxy. It can also make xyx. Oh, with 3 it's not the same. Okay. You can take xx from there, xx from there, z from there, and then you put the y back. But the original xx and y stay in order. I could attempt to confirm this by writing a brute force method that does all of the combinations of omega. So this is... Oh no, not all the combinations. That doesn't make any sense because you can chop bits out. That's what's making it annoying. The fact that I can chop pieces of this out. So I guess this one wouldn't work. But yxx we could do. What's yxx say? We can make yxx, we can make xyx. Ah, see that's a valid one. But doesn't fit that rule, so that's not the way. Something about disjointed substrings. Like the fact that you can find xxy but broken up inside this. So, can we do progressive membership? Member swap is what you want. Yeah. What's the thing again? xxy. Oh, sorry. xxzy into xxy xxz. Oh. That is the way around we wanted it. Yeah. Alright. And... Oh, no. In this case, we just want membership. I was thinking the progressive membership clearly shows that this is xxy. And then we've got xx and z. And in this case, the individual piece being in order, is that important? I don't know. The membership is not the one. It's the order is important. The order is important. But the multiplicity is not. Well, what? But then finding... PP. Finding them in there. Is that important? We get our surprising one again, the xy. xxy in xy and... Yeah, exactly. What? Ravel over enclosed still works. xyx. Why the hell does omega not match that? Well, the answer lies in repobg. Oh, I don't have repobg here. So not quadesi dot dialog utils repobg. Okay, I do have it, just not as a user command. xy. Oh, it's a one element vector, whereas this is a scalar x. Wow. So now we're going to do some little nonsense kind of. It said omega equals. Yeah. And slash equals. And slash. Oh no. Pick. And slash that. This seems like dirt. I mean, we know we can't do match each. But I assume since they're strings. Oh. Oh, okay. What? Do we have to... Oh, is the... Okay, also, go back, double check. Is the whole task... Do we have to use up the whole of the input strings? Like in this case, it's 1, 2, 3, 1, 2, 3. In this case, it's 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So in this case, progressive membership would also be a good test. X, 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 Z, Y, X, X, Y, X, Z, X, X, Y cannot be gotten from Y, X, and X. Is there an easier way to check No, I've got to do it this way because I don't want to be flattening the things to compare the elements. Oh, we could do match over comma. I think that might work. Each. What? X, Y. Oh, yeah, of course. Right, yeah. And slash match over comma each. Right, yeah, of course this one doesn't work, but we'll go back to the other test cases. You can see in this case my reasoning is taken second place to just trying things until something seems to work. Which is not really the best way to do it, but if we get a thing that works, then I don't like to complain. So yeah, the YXX doesn't work, but the XYX does work. And then XXXXZY from XXY and XXZ. And can we think of other examples? Well, yeah, we wanted to check about the multiplicity thing, right? So the idea that ABDD could be made from AD and BD, but it could also be made from pieces of AD and BDC. Alright, so this should work. ABDD, AD, BD, because A, BD, and then another D. But if we put a C there, it says no. Again, there's not a counterexample to check that it should be exactly the right number. But I guess that's what interleaving the strings means. So I think this is correct. I think this is not only correct, but also good enough. So let's create this Defen skeleton, and we'll go into the text editor. To clean up a little bit. So for one thing, we need that progressive membership in there. Progressive membership, I guess it's multi-set membership. Pardon me. Multi-set membership. We'll call it that. That's it really. Yep. Okay. What? I have to do something. Be like, yeah, there we go. Got to change something to change something. What is it? Can strings be interleaved to form alpha? In terms of explanation, I'll go through it in a second in the terp. Right, common factors as well. Yeah, let's just stick you as a one-liner. Alpha thing there. Omega. Alpha intersect over factors. Alright. I'm calling it for today. So we can erase PDI and PE, I think. And we'll pop this up for the title screen. So the two problems today were common factors and interleave string. Oh, we can make this even better if we just pop you over there. Ooh, maybe a little bit like that. What? Oh, set print width a bit higher. Okay, you to the top. Yeah, right. So the two problems today were common factors and interleave string. And common factors was basically translating the problem here. So find the factors of your two inputs and then find the intersection of those two lists of factors. And interleave string, we're using multi-set membership to basically determine if okay, hold on, let me get an example to explain this. So with XXY, multi-set. Oh, do xxxxzy interleave string xxy and xxz. With multi-set membership, we're basically asking, are there enough? So if we did it the other way round, so membership swap, swap each, nope, omega dot each alpha, nope, rank 0.99, 1, mix omega. Yeah, okay, that's a bit stupid, but we'll go with it. And alpha there. So with multi-set membership, it basically asks, are elements of alpha found in omega, and after you find one, it's used up, right? So it counts how many of them there are. So it's basically asking, are there at least 2 x's and 1 y in alpha? Are there at least 2 x's and 1 z in alpha? And this block of ones tells you that there are all of those. When we do the function the other way around like this, it tells us where the first 2 x's are, ignoring all further x's because we've run out of them, and therefore where the next y is, and xx and z. And like, I feel like, see, it's my functions worked for all the examples, and I kind of want to leave it here. But deep down I'm feeling like my logic isn't well thought out enough, because I'm thinking, yes, this tells me, and what I'm doing then is just compressing out those ones that I found and seeing if those 2 compressed out strings match the input strings exactly. I mean, why does that? If I just stick a D in there, yeah, I get a 0. Why do I get a 0? Ostensibly, this part should still give us the input strings, no? Oh, I see. It doesn't give the input strings. It gives the input strings you would want, but the extra D causes it to be a 0. And then the other way I'm thinking is, I don't know, xxy and xxz can do this. xzy and xx can't. xzy and xxy. It says yes. What would be there? xx from there. Aha. So yeah, okay. So it's not correct, I don't think. I think this is a case that should return 0, but I'm returning 1. Because you don't have enough, right? xx and then a y at the end, and just 1 xz and too many y's. I should get PDI back again, huh? No? No. Okay, just start from this point. Oh. Oops. Okay, well, ignore all that. There we go. So this time we've got the xx and the y. So this kind of tells us that the number of elements work and that they'd be in the right order. Or could work. But it doesn't tell us we have enough of them. And this is where we could do the membership over enlist. So it's alpha of the enlist of omega. Oops, sorry. Alpha enlist omega. Yeah, and here we see the gap. Alright, so this tells us we don't have enough. So the thing about compressing and comparing to the inputs, I think, tells us that we could chop up the inputs and interleave them in a way that preserves the order of elements between our inputs on the right matches the order that they would need to be arranged on the left. Right, that's what we had so far. But this simple check that they're all members. Oh, sorry, no, that's not what I'm doing here. Actually, yeah. Anyway, that all of alpha are multi-set members of the elements in omega, the enlist of omega. That tells us that we have the exact right number of elements in our right-hand strings to fulfill the left-hand string. Right? So we could put an AND in or a guard. I guess we'll go for an AND. Though actually it's more efficient if we put a guard in. Basically, this is the sort of statement. Can strings omega be interleaved to form alpha? String alpha. And the answer is 0. Unless, if we have sufficient elements, then we can calculate this stuff. Okay. Whatever. So, our test cases. Ain't that the way. Let's just have another little check. Wherever it was. XXY, interleave string, XY, and X. And this is XX, XXZY from XXY and XXZ. But not from XXZD and not from XZ. Not from XZY. And not from... Oh, you can do it with XXX. XZY, yep. XZYX is too many, but XX and XZYX should work because you can take X from the left. Oh no, it's not because of the ordering. Right, you'd have an X on the right which doesn't exist. What about XXZ? Oh, again, yeah, it does the same thing, just the other way around. Trying to think of a way to trip this up. BDDC can be made from A, C, and then it would have to be so BDC, no, but BCD, yes. I'm happy with this. I'm going to go for it. I'm going to go ahead and submit these. So, yeah. Common factors. Nice and simple. Just some maths. Interleave string. To be honest, a bit of a bugger. And I wasn't I was a lot more confident going into that problem than I was when I got to the solution. But hopefully that was some kind of adjective to watch that progression, you know, frustrating, entertaining, stupid. Alright, but that's it, and that's it for me this time. Hopefully the auto editor I can configure to make this quite okay. That's it for me this time. I'll see you on the next one. Okay, bye.